to our pop-up chemistry lab at the Ars Electronica Festival.
My name is Martin.
I'm Lena.
And today we're going to show you some oscillating reaction and some other stuff in chemistry. A little bit too hot for me today.
At first, I want to show you some colorful patterns. And for this, we need dyes, and I don't want to have colorful fingers, so I wear gloves. For the first pattern, we use methylene blue soaked in ethanol. There we add 1 milliliter of hydroxyacetone. And 1 milliliter of a sodium hydroxide solution. Wait a little bit. And after some seconds, we can see colors changing and the solution gets colorless. To see the pattern, we pour the solution into a petri dish. And you can see cloudy pattern. And we want to see it in detail. So we put the petri dish under the microscope. Turn on the light. You can see the pattern which is changing. The pattern occurs because one moment. The blue dye gets reduced by the hydroxyacetone and the sodium hydroxide solution, so it gets colorless. And the oxygen from the air oxidizes the dye again, so it gets blue or violet again. The blue dye has a different surface tension than the reduced one. So because of this occurs a flow, which you can see by the changing pattern. And because of the flow, the reduced dye comes to the surface, gets oxidized by the oxygen, and the oxidized dye, the blue one, goes down and gets reduced again by the sodium hydroxide and the hydroxyacetone, and so on.
We would like to play some background music, but we can't.
So now we want to show you the red pattern. Which we make with safranine, a red dye, also solved in ethanol. We need the same chemicals, but here we need 2 milliliters of the hydroxyacetone, and 4 milliliters of the sodium hydroxide solution. You can see the color is changing a little bit. And the solution gets partially colorless. Pour it again into the petri dish. Enter it beside. And you can see a similar pattern. It's a little bit different, more like blood vessels, not so cloudy. And we put it under the microscope. You also can see the flow because of the surface tension. And now we will show you how important the oxygen is, because when we put a glass dish onto the petri dish, so the air is excluded, you can see the motion, the pattern stops. Everything gets colorless, and when I remove the glass dish so oxygen can go to the solution, the flow and the pattern starts again. Now you can relax a little bit, enjoy the beautiful pattern on this beautiful Sunday morning. In between, we will prepare some other experiments for you.
So now we're gonna show you what happens to bad gummy bears. For our first experiment, I've prepared some gummy bears in water. You cannot smell it, but they smell really nice. And to these gummy bears, I now add some concentrated sulfuric acid. Let's see what happens. You see the solution turning black immediately. Why is that happening? The reason for that is that the concentrated sulfuric acid takes the water out of the carbohydrates inside the sugar of the gummy bears, And as you can see now, much more is happening. You see hot steam coming out. The reason for that is that the reaction is really exothermal, and the hydrates make water vapor, and also the sulfuric acid oxidizes the carbohydrates a little bit, making also CO2 and other kind of compounds that evaporate. And you can see now, oh, it's really hot. I almost burned myself again today, second time. And you see it's really a black mess. And now I'm gonna add some water to it. I'll add some water to it to cool it down a bit. Hopefully cool it down. Yeah, no, that didn't do anything. It's still boiling. But I want to show you the black mass, so I'll pour in more water. You can see that it's that there's a gas inside because it floats on the water. It's almost like black bread, but no, please don't eat it. Chemically, it's similar to coal, so almost pure carbon. That's why it's black. And I hope now it's still hot, but yeah, it's still too hot. Oh my. Yeah, now it's perfect. So you see still steam coming out, but you see this black mass. And it's funny because when you do this experiment with pure sugar, the black mass is really hard, but here it's like almost like a gummy bear, so it's really squishy. The reason for that is that the gummy bear doesn't only have sugar, but also other stuff inside that makes them flexible. Now you will see, while I clean up this mess, you will see again the beautiful patterns, and then I'll show you the next experiment. What's hot? So for the next experiment, I need three things. A test tube with some potassium chlorate, a blowtorch to melt the potassium chloride with the lighter, and again, some gummy bears. We just need one gummy bear, and I prepared one gummy bear in almost every color, and you can decide, the people online can decide which gummy bear I will choose, which gummy bear will be sacrificed to the chemistry god. So now I'm going to heat up the potassium chloride. When you heat stuff up in a test tube, please always try not to forget to open the lid, otherwise things can explode. And now I'm gonna heat it up with the test tube. This may take a while. When you heat something up, a tube or something, always try not to put the heat only on one spot. Stuff expands when you heat it up, and if you don't heat it up properly, the stuff may break. So always try to heat up glass and similar stuff, not only on one spot. Yeah, you can already see melt a little bit. Yeah, it shouldn't start to boil. That would be bad. But looking good, looking good. Almost done. Yes. So now, is there any input from the audience? Take the green one. So nobody online wanted anything, so I just take the green one, and I'll cut it in half so it doesn't get stuck in the test tube, and then I'll add it. Too dumb to cut with a scissor apparently. Oh, this gummy bear is struggling. Oh no, I got it. So now I'll add it to the test tube and let's see what happens. And nothing happened. Why did nothing happen? Let's try it again. Oh no, it's happening. Murphy's Law. Good thing I didn't have my hand over it. Oh my god, what's this? Get it! Put it back in! Put it back in! Let's throw in the other part, see if this works better. Go in, go in. Okay. The gummy bear doesn't want to go. Oh, this one is really struggling. Yeah, but it couldn't escape. It couldn't escape its. Let's try a second one. If that one works better. And the answer apparently is no. Oh, okay. The test tube is already blocked close. Oh, yeah, no. So what's happening here? It's again the sugar in the gummy bear that reacts with the potassium chloride. The potassium chloride is a strong oxidizing agent. It reacts with the sugar to form carbon dioxide and water. And the potassium chloride itself then forms potassium chloride. Yeah. The gummy bears are struggling today. Don't want them to suffer any longer. So I will clean up this mess again, and then I'll see you with the last way of how to torture some gummy bears. As it was. Again. So for the last experiment, I'm gonna use some liquid nitrogen. We already burned them, gummy bears, and now we're gonna freeze them. So I'm gonna add some liquid nitrogen. You see it's really cold. It's so cold that the water vapor in the air builds small droplets, meaning water vapor that you can see. Now, liquid nitrogen is really cold, like minus 200 degrees approximately. But it's still not that dangerous. Why? Because it's so cold that when I put my finger into it, the liquid nitrogen immediately evaporates and the cold doesn't really touch my finger. But please don't try to get anything into some cavity or something, because that would be really dangerous. So now I'm gonna add the gummy bears into the liquid nitrogen solution. Yeah, this is not really cold. I don't want myself getting frozen after being burned. So now the gummy bears are really cold, and I can show you now what happens with them after I pour them out. Try to do it really slowly. So they're really cold now. You can see that one of them is already broken, the white one. And when I will take one, it's really cold. I take one and just drop it a bit. You will see it immediately shattering. And to be more fun for me, I will now use a hammer. Yeah, okay. So here, the reason is mainly not the sugar. It is the sugar too, but it's mainly the water that's really frozen stiff. All other material also gets really bristle when it's really cold. We could also do the same experiment with, for example, flowers or something, or other living tissue. With my finger, for example, but I won't do that. So now we've shown you 3 different ways. Now we've shown you 3 different ways on how to torture gummy bears. We will clean up this mess, and you can watch again some beautiful oscillating reactions. If you've got any questions, please ask us in the live feed.
Thank you for watching.
And see you next time.
Safranine is also a fluorescent dye, and when we light with UV light on it, you can see it glows a little bit orange.
Move it shortly. Move it. See that? So this is without the UV light, and this is now with the UV light.